Hello, my name is Jeff Baggett, and today we're talking about planet Earth, how it developed from its initial stages to the point where it could host life. Our planet is very unique in this regard, and certain key developmental steps had to take place in order for the planet to be habitable. Today we're going to look at two different accounts of these key developmental steps. One is the biblical account known as the 6 days of creation, and the other is the scientific account, mostly through the field of geology. And we're going to be looking at similarities and agreements between these two accounts. For the Bible, I will be reading from the Old King James Version, which was first published in the year 1610. But the account of creation in that book was translated from ancient Hebrew manuscripts that were about 3,000 years old at that time. For the scientific account, we'll be looking at the geological timescale as put forth by the International Commission on Stratigraphy. The geological timescale is a history of Earth, and it's based on the law of superposition, which states that the Earth formed in a series of rock layers, one on top of the other, and as you investigate down into these rock layers, you're going back in time, and clues can be found that reveal what was going on with Earth at the time the rock layer was laid down, whether those clues be fossil evidence or geochemical signatures in the rock. Now, whenever you're making a comparative study from two such different disciplines, certain challenges will arise that need to be addressed. One challenge here is intent. The Bible was never intended to be a scientific text. It's written as a book of salvation for mankind, yet it does discuss these key developmental steps on its first page, which is referenced to later in the Bible as the foundations of the world. A second challenge is language. The Bible doesn't use many of the common scientific terms we know today. Words like plate tectonics, DNA, even the word gas is not found in the Old Testament whatsoever. A third challenge is volume. Whereas the field of modern geology has put forth countless books and research papers covering this subject, enough to fill libraries, the biblical account is written on only one page. Therefore, it is to be looked at as a brief and condensed account. It does not dive into the details. It only says God called something forth and it was so. Now, understandably, the scientific mind would have preferred that the Bible explained in depth all of the processes and mechanisms that brought these developments into fruition, but had it done so, this entire book would probably not be enough to cover what went down on the first page. So, with these challenges in mind, let's get started. The geological timescale has 4 eons. Beginning with the Hadean, then the Archaean, the Proterozoic, and the Phanerozoic. And each of these eons on the time scale is broken down further into geological eras. And some of those eras are broken down even further into geological periods. But for today, we'll mostly just be dealing with the 4 eons. If you would like to see the full geological time scale, just Google it up. Wikipedia does a good version of it, but there's others. So the history of Earth begins, geologically speaking, with the Hadean Eon, which is named after Hades, the Greek word for hell, because it's believed that the Earth formed due to a process called accretion. Accretion is cosmic rocks smashing into each other and fusing together until they form one great big rock, the surface of which would have been extremely hot, molten magma everywhere, and totally uninhabitable, therefore hell. And the initial geophysical estimations of how long it would take for an accreted planet the size of Earth to cool down sets the boundaries between the Hadean and the Archaean eons. But once it did cool down enough to host water, then ancient Earth was a barren water world. There's a number of studies on this subject. This one can be found at newscientist.com, a credible scientific publication. And the barren water world is based upon 2 concepts. One is that the water we have on Earth today was always here since the Hadean. It was just a matter of the Earth cooling down enough not to boil it away. The second concept is that the Earth's surface was relatively smooth during the Hadean compared to today. Since this was a time before plate tectonics, the Earth didn't have near as many mountain ranges as it does now, nor the deep oceanic trenches. Right now, 70% of the Earth's surface is covered in water at an average depth of 2.5 miles. So if you were to smooth out the surface of the Earth today, that is, bring down most of the mountain ranges and fill up the deep oceanic trenches, then the waters would flood over the top, and stretching 70% coverage to 100% coverage shrinks the depth from 2.5 miles to 1.5 miles deep. But that's very rough calculations. There's a number of other factors that would have to be considered, not the least of which is that it's impossible to know how much water the Earth has lost since the Hadean. Now, this whole Hadean-like scenario for Earth's beginnings was set in stone in geological institutions up until about 20 years ago, when the discovery of zircon crystals has brought all that into question. These zircon crystals, which date throughout the Hadean, some of them relatively close to the beginning, have geochemical signatures in them that state that not only was the Earth not near as hot as the Hadean scenario when they formed, but that the Earth was already hosting water. If you'd like to study that further, it's known as Cool Early Earth. John Valley was the leading geologist on this study. Now, the geochemical evidence in these zircon crystals, which cannot be denied, does not coincide with the believed to be necessary cooling down time for an accreted planet the size of Earth. And that difference is yet to be reconciled. But what's not in question is that once the Earth did cool down, whenever that was during the Hadean, that ancient Earth became a barren water world. So that's the first geological eon. Let's look at the first day of creation. And the Earth was without form and void, and darkness was upon the face of the deep, and the Spirit of God moved upon the face of the waters. So the Bible also describes ancient Earth as a barren water world, and it's from here that God will begin to call forth the key developmental steps that would prepare the surface to host life. Okay, the second geological eon is the Archaean, and this time is known for intense volcanic activity. More so than any other period in Earth's history, multiple volcanoes, whether they were poking up through the water surface at this time or still below the surface of the water, spewed out gases that blanketed the planet and initiated our atmosphere. It was not the atmosphere we know today. It was carbon-rich, did not have breathable oxygen, therefore would not have produced clear daylight at the surface, but more of a red or orange haze. But this early atmosphere did act to stabilize the climates of early Earth and protect it somewhat from the temperature extremes of outer space. And eventually, that atmosphere would change over to the oxygenated atmosphere we know today. That whole event is known as the Great Oxygenation Event. And later on, the geological timescale will show evidence of that changeover. But first, let's look at the second day of creation. And God said, "Let there be a firmament in the midst of the waters, and let it divide the waters from the waters. And God made the firmament, which divided the waters which were under the firmament from the waters which were above the firmament. And it was so." The word firmament is the Old English word for atmosphere. So the Bible is saying that God raised waters from the waters to create the atmosphere/firmament, whereas geological sciences says that it was initiated by volcanic outgassing. Well, if you go to volcanoes.usgs.gov/VHP/gas, USGS stands for United States Geological Survey, our official government office on matters of geology. VHP stands for Volcanic Hazards Program. But if you type in all these characters and hit enter, it will take you directly to our government's page, which states that of all the gases released during volcanic activity, by far the most abundant gas is water vapor. And again, the Bible doesn't use the word gas at all. In this case, it just says waters in the plural. And soon the Bible will give indication of the oxygenation of this atmosphere. But first, let's look at the third geological eon, the Proterozoic. And during this time, land masses emerged from the waters in the form of continents. And due to plate tectonics, these land masses shifted around the surface of the earth, would smash into each other, and this helped to form many of the mountain ranges we know today. Then they would break apart, shift around, and smash into other continents. This whole process is known as the Wilson cycle, named after John Tuzo Wilson, one of the early pioneers of plate tectonic research. Now, occasionally during the Wilson cycle, all of the available land masses on the surface of the earth at any given time would be combined into a large singular continent. Whenever this would happen, it's known as a supercontinent. Pangaea is the most famous of the supercontinents, but that would come later on during the Phanerozoic eon. During the Proterozoic, Rodinia is the name of the most notable of the supercontinents. Okay, that's the third geological eon. Let's look at the third day of creation. And God said, "Let the waters under the heavens be gathered together unto one place, and let the dry land appear." And it was so. A couple of things here. The word gathered is a verb, action word, indicating an activity or a process. In this case, a process similar to the Wilson cycle. Also notice it says that all the waters were gathered into one place. Well, if all the waters are in one place, then all the land occupies the other place. And that indicates a supercontinent, much like Rodinia. Okay, day 4 of creation has an interesting line in it when talking about the sun and the moon. It says, "And let them be for lights in the firmament of heaven, to give light upon the earth." And it was so. This is the first mention in the Bible of daylight at the surface of Earth, which is an indication of the oxygenation of the atmosphere. For you cannot have clear daylight at the surface without such. Mars has a light carbon atmosphere which produces a pinkish or rusty color haze at its surface. Venus has a very dense and heavy carbon atmosphere which produces a deep red or sometimes a deep orange at its surface. The other terrestrial planet in the solar system, Mercury, is too close to the sun. Every time it tries to develop an atmosphere, the solar winds blow it away. So Mercury is like our moon. The sun reflects off the rocks and the dust and creates a white glow around it, but that white glow doesn't rise up too far before it gives way to the darkness of outer space. In fact, outer space isn't just dark, it's a heavy blackness, and which is counterintuitive because the biggest object in the solar system, the sun, is shining 24/7, yet it does not illuminate the atmosphere like daylight on planet Earth. Let me explain how that works. When a ray leaves the sun, it has several microwave energies that are bound together within the ray. They're called microwaves because they always travel in a wave fashion, and some are more intense than others, which is measured by their wavelength frequency, and that's measured from the top of one wave to the next. You can also measure the troughs. It's always consistent. And these microwaves, according to their intensity, all emit a different color. And also, as far as their intensity goes, the more intense their microwave frequency, the more radioactively hot they are. The more elongated they are, the more radioactively cool they are. And since these microwaves are all bound together within the ray, their colors are bound together also. And as we've learned in elementary school art class when experimenting with primary colors, if you combine all the colors together, you get black. Therefore, outer space is black. But an oxygenated atmosphere like Earth can translate that sun ray into clear daylight. To understand that, we need to look at Earth's atmosphere. Rising up from the surface, there's 5 main layers to the atmosphere. the troposphere, the stratosphere, the mesosphere, the thermosphere, and the exosphere. And within these layers are even more layers. And the reason why atmospheric sciences has gone so far to categorize all the different atmospheric layers is that they all have their own elemental gas compositions. And according to their different compositions, they can all perform different effects when it comes to supporting and protecting life here at the surface of the Earth. And those differences can be quite dramatic. For an example of that, whenever you're on the surface of the planet Earth, the higher in elevation you go, the cooler the temperature drops. Well, that temperature drop continues as you go through the troposphere, the stratosphere, and into the mesosphere, where the temperature is about 160 degrees below freezing Fahrenheit. But when you go from the mesosphere to the thermosphere, the temperature jumps to over 2,000 degrees above freezing Fahrenheit. And these two layers are separated only by a thin invisible layer called the mesopause. But as I said before, it is their different elemental gas compositions that can perform such dramatically different effects. So as the sun ray beams down through the Earth's atmosphere, the first effect that happens is called diffusion. That happens somewhere up in here, and what diffusion means is that the bond that these microwave energies have together is broken. They're all still heading down toward the surface of the Earth, but they're no longer bound together. In fact, the sunbeam, as it comes down, begins to fan and broaden out as it comes through our sky. And now that diffusion has taken place, the next effect that can happen is called scattering. That happens in the stratosphere, and it deals with the particular microwave energy that emits a blue color. When that microwave hits the stratosphere, it scatters in all directions, up, down, sideways, every angle. And this is the reason why we have a blue sky. And the third effect, probably the most important when it comes to supporting and protecting life here at the surface of the Earth, is called absorption. It happens in the ozone layer, the top of which is somewhere near the bottom of the stratosphere. It's a fluctuating thing. And it deals with the particular microwave energy that emits an ultraviolet color, which is the most radioactively intense of the microwaves coming from the sun. What the ozone layer does is absorbs 80 to 90% of the ultraviolet and allows 10 to 20% to reach the surface of the Earth. Again, it's a fluctuating thing. But it's very key to life that 10 to 20% reach the surface of the Earth, for the vitamin D that life gets from the sun is from the ultraviolet microwave. But if all the ultraviolet microwave coming from the sun was to make it to the Earth's surface unabated, well, it's just too radioactively hot. No soft tissue could survive. All plants, fruits, skin and flesh, eyeballs would soon fry to a crisp. This is why there's always such a scare whenever a hole is discovered in the ozone layer. But fortunately for us, if left on its own, the ozone layer repairs itself relatively quickly. The end result of all this diffusion and scattering and absorption is clear daylight here at the surface of the Earth, which is ideal for life. Not just vision, but photosynthesis operates most efficiently at clear daylight. And photosynthesis is the foundation for the entire food pyramid of the planet. So think about all the diversity of life that lives on the surface of the Earth today. All the varieties of plants and bugs and animals and mammals, and how successfully life thrives at the conditions afforded at the Earth's surface. And now think back to the very first life forms to ever appear on the surface of the Earth. No matter how many years back you believe that was, the Earth has had a stable and wondrous atmosphere/firmament in place, protecting and supporting that life. And this brings to mind a particular biblical passage, which is Psalms 19 verse 1 says, "The heavens declare the glory of God, and the firmament shows his handiwork." Okay, moving on to the fourth geological eon, which is the Phanerozoic, and which we are still living in today. We're up here near the top, but it begins down here with the Cambrian rock layer, which is pretty much the most studied rock layer on Earth, for it was very fossil rich. They were oceanic marine creatures And the rock layer shows that when it was laid down, the waters of Earth was just teeming with life, not just in population, but a broad diversity of creatures. The largest of which was about 3 feet in body length. And all this is an indicator of at least the turning of the corner of the great oxygenation event, for the planet cannot host so much life and creatures of such size without sufficient available oxygen in the atmosphere. In fact, there was so much life going on in population and diversity that it's known in scientific circles as the Cambrian Explosion. This is a fun one to look up. Lots of trilobites and other cool critters that were living on the surface of the Earth at this time. But the explosion factor causes a problem for science. Not so much in population, but in diversity. For these creatures just suddenly appeared on the fossil record. And that's not how diversification is supposed to take place. Diversification is supposed to come through very small incremental changes from one generation to many other generations, and would take an extremely long period of time to complete. But that's not what happened here. 90% of the creatures of the Cambrian have no prior relative on the fossil record. And science has yet to come up with a satisfactory explanation for this sudden appearance of diversification. But let's look at the fifth day of creation. And God said, "Let the waters bring forth abundantly the moving creature that hath life, and fowl that may fly above the earth in the open firmament of heaven. And God created great whales, and every living creature that moveth, which the waters brought forth abundantly after their kind, and every winged fowl after his kind. And God saw that it was good. And God blessed them, saying, Be fruitful and multiply, and fill the waters in the seas, and let the fowl multiply in the earth." Keeping in mind that the biblical account of creation is a very brief and condensed account, take note of the order of life forms that's listed here. First it lists oceanic creatures, and then terrestrial creatures, the birds, and then creatures of great size, the whales. Well, you'll find that that order is in step with the fossil record. Also notice the word abundantly is used twice here. Once in population, when the creatures are instructed to fill the seas, and the second time in diversity, when it says every living creature that moveth. Well, that word abundantly is synonymous with the word explosion that science uses to describe how life came upon the earth during the Cambrian. Day 6 of creation states that the land animals we know today came into existence, followed by mankind. And that's also consistent with the fossil record. Now, at the very beginning, I note that the geological timescale is based upon the law of superposition. That idea was first being kicked around in geological circles about 300 years ago. And then along came a brilliant man by the name of Nicholas Steno. And it was Steno's research which brought into clarification how that law works. So much so that the succeeding geologists can practically apply the law of superposition out in the field of study. For this reason, Nicholas Steno is known as one of the founding fathers of modern geology. And it's a little of his research, but mostly the research of the succeeding geologists, which comprises and organizes the geological timescale. And it's from the geological timescale that science can say without a shadow of a doubt that the very first life forms on Earth were oceanic marine life creatures. Well, more than 3,000 years before Nicholas Steno was born, the ancient Hebrew manuscripts already made that claim. The Bible states that the very first life forms on Earth were oceanic marine creatures. But more so than that, or any of the other agreements or similarities that we discussed here today, is that these key developmental events come in the same order in both the two different accounts. And that's the most compelling part of this discussion. Well, I hope this gives you enough to think about for a while. I encourage you to investigate for yourself any scientific research that I referenced here today, and also read the first page of the Bible, the King James Version, and come to your own conclusions on the matter. And if this is the type of discussion that you like, keep an eye out, for there's more secular scientific research going on today which has similarities or agreements with the 6 days of creation. And we'll be coming back at you with that later on. Stay blessed.